But in this presentation, I will explain you, or kind of continue where Mika left us, how OPC UA really enables smart manufacturing in practice. First of all, what is smart manufacturing, or what is smart factory? The Internet of Things is actually a wide area, and in America they have this internet in the IIC, the Internet, what is Industrial Internet Consortium? Yeah, starting very well this presentation. But that's a really wide scope. So they have smart healthcare, smart cities, all that's covered. Whereas smart factory is only covering the manufacturing, and Industry 4.0 is only concentrating on the smart factories. And that's what OPC UA traditionally is coming from. We don't really have anything against going to the other smart parts and taking over the whole industrial internet, but it traditionally is coming from the manufacturing, and we are concentrating mostly getting that right. And also the Industry 4.0, which is driving now the development in Germany, but all over the world, is concentrating on the manufacturing mainly. There are a lot of new global trends for new manufacturing requirements. We need more individualized products. We need faster go-through times. We need different customer-driven products, and more flexibility in general for the production in comparison to the traditional world. And that creates new demand for new ways to manufacture. So there are different target criteria for the smart factory. This is coming from German Smart Factory KL studies. That's a kind of initiative that's really looking at the future ways to arrange the manufacturing as smart factories. And we have a pointer here. Nope. Okay. Okay. Yeah. So there's different needs, especially more flexibility that's required. But in practice, what we are concentrating on is the networking of IT systems needs to get more advanced all the time. On the other hand, we can compare the production systems of today and past, like the manufacturing 3.0, which was very hardware-based, and this kind of traditional automation pyramid that all of you are very well aware of. The main difference here also is that the product is separated from the production. But it's still very hierarchical-based communication. We have these different levels in the communication. But when we move to Industry 4.0, the picture is kind of scattered, fragmented. We have smart products also that can be connected to the production, but different parts of the production will not be arranged in a hierarchical way anymore. Everything will be connected to everything. And that brings more flexibility to the system. And the communication among all participants is the key to make this happen. There are manufacturers, especially in Germany, the car manufacturers are looking for new ways to arrange the production line. The traditional assembly line will be going out because that's a very rigid one. It's designed, the assembly line is designed for making one product very efficiently, but it's not flexible if you need to change the product, if you need to make more individualized products that are going through different paths in the production line. There are ways to use cellular production. The product itself can take different routes on the production system, and there can be different vehicles or even drones taking parts between the production cells in the market. KUKA Robotics is designing cellular production or matrix production, where we have different production cells consisting of robots, for example, sets of 4 robots that can assemble different parts together, and then we have AGVs, the automated guided vehicles that can transport the product or the parts between these cells. And each cell here can be reconfigured for different assembly issues or different parts of the production. And this is very dynamic process, and also the active communication between all the components is important. So these components will be kind of individual agents working here in the line and talking with each other, exchanging production orders with each other. One key thing here is also that the logistics is separated from production. So there's a warehouse, there's the AGV pool and tool store, and the production is happening here on the shop floor, and there are these production cells that are arranged in a matrix on the floor. And what's really good in this one is it's really flexible for the size. You can just add more production cells if you need more capacity to the production. Also, it's reconfigurable. If one of the cells goes out of order, you can just reroute the parts through another cell on the shop floor. Okay, and in Germany, we have this Industry 4.0 reference architecture model that Mika already explained in his presentation, and that's now drawing out a kind of complete picture about arranging the future manufacturing in different perspectives. So there's these 3 dimensions: the life cycle management, the hierarchical levels of the production, and then also these communication layers, starting from the real assets, going more towards the virtual communication, information, and functional parts. That's more like a software part of the system. And the main thing here is that the model is gathering together different standards that already are existing. It's not creating that much new standards, but gathering different standards that already are defined and trying to say that if we want to make things in a standardized way, we just need to use the standards. And the idea is that everybody that's working on this kind of concept is talking with the same terms, with the same concepts about these things. So if we look at this separation between the real world and the digital world, the idea is to bring a digital component called administration shell to cover all physical things. And then we can communicate with everything. We can connect all the parts in the Industry 4.0 communication. And everything needs an administration shell to be able to communicate in this Industry 4.0 network. And there's a lot of things that need to be considered, very basic things like identification, semantics, communication, that all of this can really happen in practice. So it's really low-level stuff that's going on there. And we see communication, a key part here again, of course. And only on top of this, when this is standardized, we can talk about standardized functionality and so on. And an important thing is that security needs to be taken care of on all layers of this system. And we need worldwide standards to make this really happen in practice. And that's what the Industry 4.0 is trying to put out. And here comes OPC Foundation to the play and brings OPC UA. That is interoperable communication standard but it's also bringing data modeling capabilities, so we can build on top of the communication, we can build semantic modeling and the information, which is even more important. So I would like to see the communication problem solved already, and rather talk about what is the information and standardize that. And security is also brought with OPC UA built in to the communication, and we would also like to see that problem solved. It's there, we don't need to know too much about it because it just is there and we don't need to care. That's how I would like to see. So the data modeling would be the main thing that we want to concentrate on after this. And Andreas Fath talking more about the modeling stuff later on. But that's something that OPC Foundation is trying to establish, that we can concentrate on bringing this all standardized as well. So the OPC Foundation is an international organization that's comprised of member organizations like Valmet and other key players. All the major automation vendors are part of that. Today the number is over 600 already, and most of that is in Europe, or at least around half of the members are from Europe. The OPC Foundation is providing different deliverables that are available from GitHub, the basic stack components that are the low-level communication components. And on top of that, we have different products in the market that help creating really good level products in practice. And this whole technology has already been developed for over 10 years, so it's really on a high level today. And there are certification labs that ensure that the products are also interoperable with each other. And that's what the OPC Foundation wants to emphasize, that products need to go to the certification, so then the end users can really trust that they are functioning as expected. And the foundation is creating an ecosystem with toolkits and educations around it, so different companies are arranging workshops and providing tools for making this easy. The whole technology is, someone describes it, it's very complex, but when we have good tools that already are implementing the details, the idea is that for the end user it should be easy to use and easy to configure. OPC Foundation has just announced a new president. Stefan Hoppe took over from Tom Burke, who was the president for the first 20 years or over, and did a good job in really evangelizing about the technology, making a lot of connections all over the world. And he's still working in the board and doing this stuff, going around the world talking about it. But Stefan already has been active for several years. He started arranging the OPC Day Europe's like 2011. We had the first day, and with Stefan we've been working together to really take OPC further in the world. But the main thing now with the modeling stuff especially is happening with collaborations, and that's where these guys, Tom Burke and Stefan, are playing a key role. They're establishing these collaborations with different standardization organizations and different other organizations in the market. And the key today is VDMA, and Andreas Fath from VDMA will be talking more about that cooperation in his presentation. They are now taking over of organizing and kind of coordinating the collaboration work as well, so that the different groups that are bringing new information models also are working together to ensure that those models are not too separate from each other. In the world, we have the Industrial Internet Consortium in America, in Europe, the Industrie 4.0, In China, they have the Made in China 2025 initiative. In Japan, they have this industrial value chain initiative, and in Korea, they have the manufacturing innovation initiative 3.0. So there are a lot of similar type of kind of programs going on everywhere in the world, but I think Industry 4.0 is leading the way. They've outlined this reference architecture model, and everyone else is trying to follow that work. And that's a good thing, because then we will have maybe just one model for the whole world, how everyone should do these things. So now, if we look at the industry or reference architecture model, OPC UA really fits in here. So it enables to accomplish the communication, but also the information part of the model. And on the side, we have these components. For example, for robots, we have the digital component administration shell, and OPC Foundation is bringing the companion specifications that enable the administration shells also to implement these information models and be able to provide the standard interfaces out. Also, this Industry 4.0 communication is OPC UA in practice. That's already been defined, that every Industry 4.0 component must be able to do OPC UA communication. Regarding security, OPC UA has its own security implementation, and the first question always is that, is it reliable? But the good thing is that in Germany, they already evaluated it by German governmental institute, the BSI, did a security analysis a couple of years ago, and the results were saying that if you use security, then you have a secure communication. OPC UA still leaves it optional. When you configure the connections, you can leave the security out, or if you go really low-level devices, the security might be too heavy to implement in those parts on a sensor level, for example, then security is optional. But of course, we always recommend that you use the security, and with the security, you can really go out of the production networks to the higher level office networks and even to the internet. And if you configure it right, it's secure. Okay, and finally, I'm showing you a use case of SAP, who has also been implementing OPC UA for several years already. They have a component called plant connectivity. That's an OPC UA component, enabling to bring all the manufacturing information to their ERP system. But they also showcasing a production line where OPC UA is used for so-called agent-based MES system or production control. And you could say that they are talking about the service-oriented architecture, which OPC UA actually is establishing, and it's reshaping the automation pyramid. That's how they show it. But this has been demonstrated at the Hannover trade shows, and in practice, the idea is that there are different components, different assets, transport systems, robots, cameras, printers, whatever, that are creating the production line. And then there's this SAP plant connectivity tool that's connected to the SAP data center. And all of these are both OPC UA clients and servers. And so OPC UA is a client-server communication protocol, meaning that there's always a kind of passive component, the server, that's ready to serve whenever the client component makes a request to do something. Request information on request and operation from the other system. And with this means any component here can make requests for each other. They can ask even higher level tasks like do the job, and when the other part is ready, it can inform that the job is done. And they're only using OPC UA method calls. They don't need any handshake mechanism that you need in a traditional communication if you create this without any method calls, if you try to do the connection with just variables that you traditionally do with the PLCs, for example. So that's the clever part here. And these are all hardware components, so you don't need any PCs in between or anything like that. That's been traditionally a limitation. So, for example, we have a smart robot which has a camera as part of it, but the plant connectivity is just making an order to the robot. It doesn't know the robot has a different component, the camera, but the robot is then calling the camera to take a picture and analyze it. And when the job is done, the robot is just sending a message back to the high-level system that I'm ready. And with this kind of communications, the whole production ordering system can be very flexible, dynamic. Each component can ask other components to do different parts of the production whenever they need it, and they're calling it like an agent-based production, not monitoring, but production control. Okay, so I mentioned that OPC UA is a client-server communication that comes from the past. The whole development of OPC actually already started in 1990s. We were talking about OPC Classic back then. That was a really well-established communication protocol. We called it OLE for process control. That's where OPC comes from. And OLE was the old Microsoft technology inside Windows operating system. Nobody really wants to talk about it anymore. So please be quiet, yes. But it managed to establish a very good set of separate actually communication interfaces for transporting current data, which is under this data access protocol, meaning how do we exchange measurement data between two systems. The current status, for the current temperature of the, for example. Another set was alarms and events that defines how you monitor just different system alarms. For example, if the temperature goes out of limits too high, we get an alarm. That's the only thing we are interested in. We don't want to monitor all the samples of the temperature all the time. So we can just monitor those events. And then the third one, major one, was historical access. If I just want to go and check what were the temperatures last week, for example, OPC defines how you get that from another historical database, for example. And that was all established, but it was mainly working on this level, the IT network, HMIs, and the machine control PLC, but the PLC couldn't do OPC, so we always had to have an OPC server on the PC level, and then we could do the communication between these components. It was very limited in practice, because we can't really go safely out of network borders. But unfortunately, this technology is still mainly in use in manufacturing plants of today. Also, for the last 10 years, we've already had the alternative available. The development started over 10 years ago, and the first version of OPC UA was established 2009. And that enables now communication between the real hardware components. They can implement OPC UA in them. We don't really need to have the PC on this level to start OPC communication. And also, because of the built-in security, we can go on higher levels to the SCADA, MES, ERP levels. Well, I would say SCADA level is actually on this level usually. That's where we are today. And I would like to emphasize that this is really well established. There are good level of products, and today in this event we have more sponsors than ever because there are more products that are really selling today and people are really implementing this stuff. And Jukka Peltola will be talking about the real case where they built totally new greenfield factories where all the communication is based on OPC UA. So all that can be done today. But then we have the future coming, and OPC UA is just extending all the time. It's going off the limits, I would say. There's a new communication alternative called PubSub, which actually means two different things. There's a controller communication, which enables us to go even lower to the field level. And the other alternative of PubSub enables us to go to the cloud systems. The common thing with both of these PubSubs is that we don't really need to have this tight client-server communication channel open all the time, which is required in the traditional OPC UA, or current OPC UA. The PubSub enables you to communicate over kind of less reliable networks. Or when we go down here, we don't really need to acknowledge all the messages, and then we can go really fast and even go real time. That's the target now. I always used to say that OPC doesn't intend to be real time at all, but things are changing. I can't do anything about it. So today, most of the talk is about TSN, and even now we are talking about OPC UA going over 5G, which hasn't established. Both of these are coming technologies, and OPC UA will be taking advantage of both of them to make it real time in practice. And Matthias will be talking about the PubSub technology more in his presentation. So in practice, the picture will be looking like this. So this is a traditional IT network where we have OPC UA today. We will have the management shells over all the physical systems, and the OPC UA Industrie 4.0 communication can go over here. But in future, we can go to the cloud systems through different relay brokers with OPC UA as well. And on the other side, we can use OPC UA over TSN or without TSN here between the controller communication and let the robots communicate with each other. So if you remember the beginning of my talk, I was showing these visions of KUKA Robotics, that they are actually building these systems, the matrix production. All these components can communicate real time with each other over OPC UA. And they can exchange the semantic information with each other. It can become really flexible, like we see in this SAP example. When every component can communicate OPC UA, they can be really clever, and we can really have smart manufacturing in future through this. Okay. OPC Foundation is publishing these brochures that you already have there on the table. There's a new version, it's version 8 updated, and it's also available from the internet, from the OPC Foundation website. There are OPC UA videos available from the OPC Foundation channel. There are more videos coming up all the time. This year I was recorded at the VDMA office as well. I did the getting started, so if you really want to know how you get started with using OPC UA or developing OPC UA, that's something to start from. But there are also technical presentations, and now a lot of this collaboration work is explained through the videos over there. So you can really have a nice weekend watching all these videos. OPC Foundation also has a newsletter, and you can just sign in to that if you want to learn about all the news that are coming in future. We are living in interesting times. Okay, with that I end my presentation, and thank you for your attention.